Hello, and welcome back to the Umbrella Academy. In this lecture, we will discuss ring flipping and cis-trans relationship in cyclohexane chair conformation. First, we will learn shortcut to draw the cyclohexane chair. Consider this planar form of the cyclohexane. I am marking each carbon with a different color dot. You can instead number these carbons. Select any two parallel bonds from the planar cyclohexane. Draw the same dots tilted right. Connect the dots to make two parallel lines. Keep the height same. The top two dots should be slightly offset than bottom two dots. Imagine this diagonal line and draw remaining two dots on this diagonal as per their connectivity in planar ring. The two dots should be slightly offset, so that their center is midpoint of the diagonal. Connect these two and these two dots, so that two parallel offset lines are formed. Now connect these two dots and these two dots. Notice that these four dots appear on the same line. This makes the chair form of the cyclohexane ring. This is the headrest at the top right, and this is the footrest at the bottom left. During the ring flipping, which is shown by this sign, the three up carbons are pushed down and three down carbons are pushed up. To draw this ring flipped form, I draw the four dots like this. Notice that these are the four dots which were previously in line on the diagonal. Connect these to form two parallel lines tilted towards left. Keep the height. The top two dots should be slightly offset than bottom two dots. Imagine this diagonal line and draw remaining two dots on this diagonal as per their connectivity in planar ring. The two dots should be slightly offset so that their center is midpoint of the diagonal. Connect these two and these two dots, so that two parallel offset lines are formed. Now connect these two dots and these two dots. Notice that these four dots appear on the same line. This makes the flipped chair form of the previous chair. Notice that headrest is now at the top left and footrest at the bottom right. Notice that up carbons in the previous chair are now down carbons in the new flipped chair. And down carbons in this previous chair are now up carbons in the flipped chair. Now, let us understand axial and equatorial positions in the chair conformation. And what happens to these positions on ring flipping. For that, I am drawing a planar form of the chair and marking the carbons with colored dots, as I did above. I am drawing the chair form using the method we discussed above. The chair conformation of cyclohexane has two kinds of positions for substituents on the cyclohexane ring: the axial positions and equatorial positions. I can draw an axis through this chair conformation. This is called ring axis. The axial positions are parallel to this ring axis. On the three up carbons, I can draw the axial positions in red color, pointing up, parallel to ring axis. These are marked as A, U, meaning axial up position. On the down carbons, the same can be drawn pointing down in yellow color. These are marked as A, D, meaning axial down position. These are the six axial positions, three up, on up carbons, and three down, on down carbons. Now each carbon has an equatorial position, which is roughly in the plane of the ring, around equator. You can get better idea of equatorial positions from this 3D picture of chair conformation. You can see that the equatorial positions are in a band around the ring and axial positions are parallel to ring axis. In the 2D representation of chair conformation, down carbons have equatorial positions pointing up, and up carbons have equatorial positions pointing down. Moreover, each equatorial bond is parallel to two ring bonds. Thus, on these down carbons, I can draw equatorial bond pointing up. These are marked as E, U, meaning equatorial up position. Likewise, on these up carbons, I can draw equatorial bonds pointing down. These are marked as E, D, meaning equatorial down positions. Thus, up carbons have axial up and equatorial down. And down carbons have axial down and equatorial up. The ring flipping is shown by this sign. I can draw the flipped form using the same method we discussed above. So that, up carbons are now down, and down carbons are now pointing up. Remember that, upon ring flipping, axial becomes equatorial and equatorial becomes axial. But positions up, remain up, and positions down, remain down. Thus, 3 red axial up bonds in the previous chair have now become equatorial, but still pointing up. These are marked as E, U, meaning equatorial up positions. Likewise, the 3 yellow axial down bonds in the previous chair are now equatorial but still pointing down. These are marked as E, D, meaning equatorial down positions. I can draw the ring axis for this flipped chair. The 3 blue equatorial up bonds in the previous chair are now axial bonds but still pointing up. These are marked as A, U, meaning axial up positions. Likewise, the 3 green equatorial down bonds in the previous chair are now axial but still pointing down. These are marked as A, D, meaning axial down positions. Let me repeat this. Axial up changes to equatorial up. Equatorial up changes to axial up. Axial down changes to equatorial down. Equatorial down changes to axial down. These up bonds are called beta bonds. And these down bonds are called alpha bonds. The up bonds are the groups on wedges in the planar cyclohexane, and down bonds are the groups on dashes in the planar cyclohexane. Thus, in planar cyclohexane, these wedge bonds are all beta and these dash bonds are all alpha. Notice that beta can be axial or equatorial in chair form. And so can be alpha bonds, as axial or equatorial. Now you need to be attentive. If 2 bonds on any 2 carbons in cyclohexane chair are both pointing up, that means they are beta-beta, then the relationship between them is cis. Same is the case if 2 bonds are both pointing down. That means, if they are alpha-alpha, then relationship is cis. However, if one of the bonds is up and other is down, that means beta-alpha, then the relationship between the 2 is trans. Same is the case if one is down and other is up, that means alpha-beta, in that case also, relationship is trans. To check our understanding, consider this planar cyclohexane. I attach substituent X on wedges. That means it is beta. In the chair form it will be either axial up or equatorial up. I am drawing cyclohexane chair using the method we discussed earlier. On this carbon, I attach substituent X on axial up position. I can draw the ring flipped form like this. We know that in flipped chair, up carbons are now down and vice versa. The axial up becomes equatorial up position. So substituent X is now on equatorial up position. I attach another substituent Y on adjacent green carbon as wedges. It means it is beta. In the chair form it will be either axial up or equatorial up. In the chair form we have already placed red carbon in up position, so that adjacent green carbon must be down carbon. And on this carbon, beta position is equatorial. So I attach substituent Y on equatorial up position. In the flipped chair, substituent Y will change to axial up position. Likewise, in the planar form I attach substituent Z on blue carbon as dashes. That means it is alpha. In the chair form it will be down, either axial down or equatorial down. In the chair form, blue carbon is down carbon, and has therefore axial as down position. So I attach substituent Z on axial down. In the ring flipped form, it changes to equatorial down position. In the planar form I attach another substituent, R, on pink carbon as dashes. That means it is alpha, which in the chair form will be either axial down or equatorial down. In the chair form, pink carbon is up carbon and has equatorial position as down. Thus I attach substituent R as equatorial down. In the flipped chair, this will change to axial down. Notice that, just like in the planar form, in the chair form, X is beta, Y is beta, R is alpha, Z is also alpha. And when the ring flips, X remains beta, Y remains beta, Z remains alpha, R remains alpha. Consider this substituted cyclohexane. I will number the carbons of ring. But this is not as per IUPAC. This is just to track carbons in chair form so as to not commit any mistake when attaching substituent groups. Amino group is on wedges, therefore it is beta. Methyl is also beta. Hydroxyl group is alpha. The chair conformation can be drawn like this. Numbering starts from the carbon-bearing methyl group. Methyl is axial up, means beta. Hydroxyl is equatorial down, means alpha. Amino group is axial up, means beta. Upon ring flipping, it will appear like this. So that up carbons become down and down carbons become up. Also axial becomes equatorial and equatorial becomes axial. But beta remains beta and alpha remains alpha. Consider this substituted pyrene derivative. Number the rings starting from oxygen. Methyl is beta and hydroxyl is alpha. The chair conformation can be drawn like this. Hydroxyl on C3 is equatorial down, means alpha. And methyl on C5 is beta. The ring flipped form appears like this. So that up atoms of chair are now down in flipped chair and vice versa. The hydroxyl group on C3 changes from equatorial to axial, but remains alpha as before. Likewise methyl on C5 changes from axial to equatorial but remains beta. Consider this piperidine derivative. Number the rings starting from nitrogen. Methyl group is alpha. And methylamino group is also alpha. Isopropyl group is beta. The chair form can be drawn like this. Methyl on C2 is axial down, meaning alpha. And methylamino group on C4 is also axial down, and hence we say it is alpha. Isopropyl group on C5 is axial up, means it is beta. This way cis-trans relationship of substituents is maintained in the chair conformation. The ring flipped form appears like this. So that up atoms of the chair are now down in flipped chair and vice versa. Methyl group on C2 is now equatorial but still alpha. N-methyl amino group on C4 is now equatorial but still alpha. Isopropyl group on C5 is now equatorial but still beta. If you don't want to miss out important lectures, then subscribe and press bell icon for notifications of new lecture uploads.